Hello. Today in this episode, we'll be talking about antiderivatives. So basically, antiderivatives are the opposite of derivatives. So first, we'll be talking about some important things to know that's part of antiderivative, the reverse power rule, the proof, and a method called U substitution. Okay? So first, we'll be talking about some parts of the antiderivative. So number one is that instead of f prime, as usual in derivatives, we do uppercase f instead of a lowercase f. So basically, uppercase f prime of x equals to lowercase of f of x. And then you always have to have a plus constant, because it doesn't really matter if you have a constant because it goes up or down anyway, so it doesn't really change the curve. Okay, now we'll be talking about the reverse power rule. So the reverse power rule is 1 divided by n plus 1 multiplied by x powered by n plus 1. Okay, so now we're talking about the proof so you can more deeply understand it. So you take the derivative's power rule, the normal one, okay, and then you really just substitute n for n plus 1. So you have n plus 1 divided by n plus 1, right? And then you have those cancel out, and then you substitute n for n plus 1, right? So you have n plus 1 minus 1, okay? And then that has x powered by n. Okay, now we'll be talking about U substitution. Okay, so basically you take what's inside, and then you really substitute with a letter U, okay? So du divided by dx, not divided by, but just like, you get it, equals to 2x, okay? And then du equals to 2x multiplied by dx, of course, because multiply. And then 1/2 of du equals to, of course, you just take away the 2, which is x dx, okay? So what we're really doing right here is that using u to replace x dx. So basically, after that, you plug it in, and then you just simplify, and then add the constant after that. In this episode, we'll be learning about integrals. Last episode, we kind of learned about antiderivatives. So integrals is really about kind of calculating like area of like a squiggly line. So the fundamental theorem of calculus, okay, is differentiation, which is derivatives, is the opposite of integrals. To calculate integral from a to b, it is the antiderivative of b minus the antiderivative of a. Okay, so now I'll be talking about some rules that you should know. Okay, it's pretty common sense, so you don't really have to worry if you don't understand it. So a to b is basically equals to the flip negative. So negative integral from b to a. Okay, rule 2 is a to a is 0. It's just there's no really place to go because it's a to a, right? Same point. Okay, now it's a to b plus b to c, which is of course a to c. Really common sense right here. And then now we have integral from a to b is when you have a constant, basically, is what we're talking about right here, is that you kind of cut off the squiggly line, so it makes it easier for you. So then it's just b minus a multiplied by constant c. Today in this episode, we'll be talking about a little bit about some tricks that you can do on your calculator. Okay, so first of all, we'll be doing derivatives. Okay, so first of all, what you want to do is press math right here, okay, and then press 8, and then you got derivatives. Okay, so basically you want to kind of type in what you want. So for example, so you can like type in your variable, so x, of course, and then you type in your equation in the brackets. So 1 plus, I'll just do example here. So right here is that we kind of type in our variable right here. We type in our equation right here, and then we type in what like x equals to right here. Okay, so then when you hit solve, you get 2. Of course, you can do it manually and do the calculator. Okay, so now we'll be talking about something about integrals. Okay, integrals is really just do something, and then you just go to 9. Yes. Okay, and then it's here. Right there's integrals. Okay, and then you kind of just type in what you need to type in. So, I'll do an example really quick. Okay, so you type in where your number goes to another number. For right now, I'm doing 0 to 2. Okay, and then I have x squared, and of course dx, which is my variable. Okay, and as you can see, my area is 2 2/3.